Imagine a world where the sun never sets or never rises, where one side bakes in eternal daylight while the other freezes in perpetual darkness. This isn't science fiction, it's the reality for countless planets across our galaxy, trapped in what astronomers call tidal locking. You're looking at a cosmic prison sentence that lasts billions of years. Tidally locked planets are worlds that have been captured by their star's gravity in such a way that they always show the same face to their sun. Just like our moon always shows us the same side, these planets have one hemisphere that's forever bathed in sunlight and another that's condemned to eternal night. How does this cosmic imprisonment happen? It all comes down to gravity's relentless pull. When a planet forms close to its star, the gravitational forces are incredibly strong. The star's gravity creates tidal bulges on the planet, much like how the moon creates tides on Earth. But here's the key. As the planet rotates, these tidal bulges want to stay aligned with the star. This creates friction that gradually slows the planet's rotation until it matches its orbital period. Eventually, the planet completes one rotation for every orbit around its star. This means the same side always faces the star. The consequences are absolutely staggering. On the day side, temperatures can soar to hundreds or even thousands of degrees. The ground bakes under constant sunlight, with no relief from night. Any atmosphere would be superheated, creating hurricane-force winds as hot air rushes toward the cold night side. Meanwhile, the night side experiences the opposite extreme. With no sunlight ever reaching it, temperatures plunge to hundreds of degrees below freezing. Any atmosphere would freeze solid, creating glaciers of nitrogen, oxygen, or other gases. The boundary between these two extremes, called the terminator line, becomes the most fascinating zone. Here, you'd have perpetual twilight, a narrow band where conditions might be just right for liquid water and potentially even life. Scientists call this the terminator habitability zone, a ring of potential life circling a world of extremes. Our own moon is tidally locked to Earth, which is why we only ever see one side. But the real excitement comes from exoplanets, planets orbiting other stars. Astronomers have discovered that tidal locking is incredibly common, especially for planets in the habitable zone of red dwarf stars. These stars are smaller and cooler than our sun, meaning planets need to orbit much closer to receive enough warmth for liquid water. But this close proximity makes tidal locking almost inevitable. Take Proxima Centauri b, the closest exoplanet to Earth. It orbits so close to its dim red star that it's almost certainly tidally locked. The same goes for many of the TRAPPIST-1 planet's 7 Earth-sized worlds, where tidal locking is likely the rule rather than the exception. What would life be like on such a world? The day side would be a scorching desert where nothing could survive without incredible adaptations. The night side would be a frozen wasteland. But along that twilight terminator line, life might find a way. Plants could evolve to always face the sun, or life forms might develop incredible heat and cold resistance to migrate between zones. For human colonization, these worlds present both challenges and opportunities. Settlements would need to be built precisely along the terminator line, with careful temperature management systems. But the constant sunlight could provide unlimited solar energy, while the eternal night offers perfect conditions for astronomy. The weather patterns would be unlike anything on Earth. Instead of day-night cycles driving weather, the temperature difference between hemispheres would create permanent superwinds flowing from hot to cold. These could reach speeds that make Earth's strongest hurricanes seem like gentle breezes. Some scientists even speculate that oceans on tidally locked planets could develop unique circulation patterns, potentially creating stable environments for marine life. The discovery of tidally locked planets has completely changed how we think about habitability. We can no longer assume that alien worlds will have Earth-like day-night cycles. Life, if it exists, might have evolved under conditions we can barely imagine. As we discover more exoplanets, we're finding that tidal locking might be one of the most common planetary configurations in our galaxy. This means that if life exists elsewhere, it might be thriving in these extreme twilight zones rather than on worlds with familiar day-night cycles. The next generation of telescopes, like the James Webb Space Telescope, will be able to study the atmospheres of these tidally locked worlds in detail. They might detect signs of life in the chemical signatures along those terminator lines. So the next time you watch a sunset, remember that on countless worlds across the galaxy, the sun never sets at all. It hangs motionless in the sky, creating a world divided between eternal day and perpetual night. Would you brave the extreme conditions to visit a tidally locked world? Share your thoughts in the comments below.